Okay, welcome. Today we are going to be talking about proportional versus non-proportional relationships and how we can use tables to determine if a relationship is proportional or if a relationship is not proportional. All right, so if the ratios or rates of two quantities are equal to one another, then the quantities are proportional. If the ratios and rates of two quantities are not equal, then the quantities are not proportional. All right, so what we're going to do is we're going to look at a couple of situations, and we are going to determine if these relationships are proportional or not proportional. So if Eric and Lucy each ran 20 miles on the treadmill at the gym, the table below shows the number of calories that they burned after 5-minute intervals. We want to complete the table and determine the type of relationship. So because we're looking at calories per minute, right, and what we're looking at, we're going to compare. So for Eric, he's burning 70 calories, and we're going to split that between the 5 minutes using that unit rate like we were working on with our last lesson. And here, 70 divided by 5 ends up being 14 calories per minute. So we're going to do that for each of these. So 140 divided by 10 is also 14 calories per minute. 210 divided by 15 ends up being 14 calories per minute. And then 280 divided by 20 is also 14 calories per minute. So we can say that the calories burned by Eric is proportional to the time because every rate is 14 calories per minute. So they are each equal to one another. Now let's take a look at Lucy's. So with Lucy's, our first one, she's burning 45 calories in 5 minutes, which ends up being 9 calories per minute. And then it's 90 divided by 10, which is also 9 calories per minute. And then 120 divided by 15 ends up being 8 calories per minute. And 180 divided by 20 is back to 9 calories per minute. So the calories Lucy burned is not proportional to the time because not every rate is the same. So for example, 120 to 15 is not equal to, actually I'm going to write this a different way, 120 calories for 15 minutes is not equal to 180 calories in 20 minutes. So when we're looking at proportional versus non-proportional relationships, it has to be the same rate every single time within our table. Another thing I want to note is that if you were to graph this, any graph of a proportional relationship, and we'll get more into graphing in our next class, our next lesson, but graphs of proportional relationships always go through the point 0, 0. If you were to make a line. Or when you would look at this, they would form a line, and they're always going to go through that point 0, 0. So if they wouldn't go through the point 0, 0, it's not going to be a proportional relationship. All right, so what I want you to do right now is I want you to pause the video, and I want you to try these two on your own, and I want you to determine whether or not each one is proportional. So pause the video, try it out, and then restart the video. All right, so 24 students for one bus gives us a rate of 24 students per bus. 45 students for two buses gives us a rate of 22.5 students per bus. 78 for three buses is 26 students per bus. And 100 students for four buses is 25 students per bus. So this is not proportional. Because in this case, each one was different. So we wouldn't be able to accurately predict how many students or how many buses we could use based on our number of students, because it was different for each one. All right, let's look at our hours worked versus our money. So if we made $36 for 4 hours, we're making $9 per hour. 72 for 8 hours is $9 per hour. 90 for 10 hours is $9 per hour. And $135 for 15 hours is also. So yes, this is proportional. And then on this one, our constant rate ends up being $9 per hour. All right, now if you could flip your paper over, and we're going to try the second side. If you wanted to do these other ones for practice, you can pause the video and I'll just give you really quickly what the answers are when you're ready. So this one is not proportional. This one ends up being yes, and it's 21 miles per gallon. I'm writing really sloppily and I apologize. The fifth one is also proportional, and it ends up being 80 cents per candy bar. And then the last one is not proportional. Now the last thing we're going to work on today is then when we have a proportional relationship, how we can use that information to complete a table. So kind of working backwards. So like I said, since it has to go through the point 0, 0, we're looking for situations where there isn't something additional going on. So if they're just simply giving us a rate, it usually is a proportional relationship. So here, Ben earns $8.50 per hour bagging groceries. So we could then predict how much Ben's going to earn for the number of hours that he works. So if he's working 4 hours and he makes $8.50 per hour, we can pretty much do 4 times $8.50, and he would earn $34 for that time. And then in our next one, we can do 8 times $8.50, and he would earn 68. Now the other cool thing, if you look here, because it's proportional, we can also see a relationship going this way. So for example, he doubled his number of hours, which means he also doubled his pay because it's a proportional relationship. Whereas here, for example, if I went from, it might sometimes work, but it wouldn't always work. So like here, 3 to 6 is times 2, and this one is times 2. So then that's proportional, but we can't say the same thing about like 3 times. So like what we would do with 3 to get 4 is not equivalent to what we would do to get from 12 to 15. So we have different rates that we would be looking at. All right, here, if it's 10, we'd be making $85 because we would do 10 times $8.50, and then 14 times $8.50 would give us a value of $119. So why don't you pause the video and then see if you can complete these next ones on your own. I'll go ahead and just fill those in for you when you're ready. So here, every 1 yard, he runs 9, or he can run 9 yards for every second that he runs. So here we had 1 second would be 9 yards, 3 seconds would be 27 yards, 6 seconds would be 54 yards, and 10 seconds would be 90 yards. If it's 30 cents per minute, 5 minutes would end up being $1.50. 12 minutes would be $3.60. 24 minutes would be $7.20, and 30 minutes would be $9. Now here, the table is pretty straightforward because it's just 7 homes per month, so we would just multiply by 7 for each of these. But then it asks how many homes you could sell in 2 years. Now the tricky thing is, because the rate is given in months, we have to do a conversion. So since 2 years is actually 24 months, in order to complete this problem, we'd actually have to take 24 times the 7, and we would end up with 168 homes that were sold.